Can anyone create a type 2, or I will? Okay. X minus 1 divided by x squared minus 1. Coming back to the previous function that we looked at, was I able to simplify x minus 2 and x minus 3 in any way? No. X minus 3 is a factor, x minus 2 is a different factor. There is nothing I can do here. Okay, perfect. What do you think we have to start with? Yes, it is type 1, type 2, because the degree in the denominator is higher than the degree in the numerator. So it is type 2. Well, what do you think I'm going to have to do this time? Exactly, thank you, Marcus. So how do I factor the denominator? Before I do anything else, I have to state how many restrictions? 2 restrictions, positive 1 and negative 1. After I write the restrictions, I can simplify and write 1 and 1. And what is the simplified form of this function? Awesome, thank you. Okay. Very good. I have to start with the domain. The domain is, do not look at this to state the domain. That's why I had to write the restrictions before I simplified. We're talking about this function, not this function. It turns out that we simplified it to that, but the domain is for the original function. Very good, awesome. Indeed, that's exactly what it means. Everything except negative 1 and 1. Let's get the chart or the table going. Sorry. Zero must be in the table at all times, even if the function is undefined there, especially if it is undefined. So for negative 1 and 1, like I did before with 3, obviously, this signifies there is nothing you can put there. We no longer look at this function now. This is our function after we simplified it. So what do you think happens? What is the difference between this factor of x plus 1 that still stays in the denominator and the factor of x minus 1 that went away? What's the difference? There must be a difference between those two. One is going away, but the function is still undefined at 1. And the other one still stays, and the function is still undefined at negative 1, right? What is the difference? What do you think? The one that goes away, open point. The one that stays and I can get rid of is, that's it. That's the difference. So the one that goes away, you will see in a moment, becomes an open point. And the other one that stays and cannot go anywhere, it must be a vertical asymptote. So x equals negative 1. X equals negative 1 is a vertical asymptote. But x equals 1 is a hole in the graph because that factor went away. You want me to write this down in words? So if a factor goes away with one from the top and one from the bottom, the function is still undefined at 1. But since x minus 1 is not left in here in the denominator, then is not that x equals 1 is not a vertical asymptote, but a hole in the graph. This one no one can get rid of. It stays, which means it will be a vertical asymptote. What is the difference between type 1 and type 2? Very simple. Type 2 has only and always the same horizontal asymptote, which is 0. Why? Because the denominator is so much more powerful, has more power than the numerator, and at infinities, that will be almost 0, because I divide by a huge number. So I can already say it, since it is type 2, And by the way, I call these type 1, 2, and 3. The book does not. It's easier for me to explain what we're doing. That's why I'm using. So you can tell anybody about type 1, type 2, and type 3, they will say, what? So I call them 1, 2, and 3, so it's easier to explain. Okay, so I have to plug in 0 to get the y-intercept. Very good. On the left-hand side of -1, -1.1, it's there. I'm not putting these numbers in the table. I'm not going to plot them. You know exactly what I'm trying to do with these. I'm trying to determine the sign left and right. I know once I write it's a VA, it has to be infinity, but I don't know the sign of the infinity. So let's plug in -1.1. -1.1 plus 1. What is the sign of the denominator? Negative. So positive over negative is? Let's plug in -0.9 plus 1. Sign. Positive over positive. Last thing I need to determine, what happens in left and right of 1. So let's plug in 1 and tell me what it is. 1/2. This time this is not infinity because it's not a vertical asymptote. So 1 over 1 plus 1 is 1/2. That's it. Now let's try to make sense of this information and graph it. I know I only have 2 minutes. So here's what I see. From 0 goes down to -infinity. Then on this side, from positive infinity, crosses at 0, 1, and then going towards 0, it goes through a hole and approaches 0. One more time. From 0 to -infinity. On this side, from positive infinity, it crosses at 0, 1, it goes through a little hole and approaches 0. When we graph functions with asymptotes, we have to graph the asymptotes first. However, for type 2, this will be an overkill. It's already there. I have at -1 a vertical asymptote. And this point at 1, if this is 1, 1/2. 1, 1/2. So now let's look at the graph again. From 0 to -infinity. From infinity, crossing at 0, 1, going through this point, and to 0. With the graphing calculator, we have no secrets. We have nothing to check, but let's do it anyway. Clear everything. So in parentheses for the top, x minus 1, we have to put in the original function divided by x squared minus 1. There is no point in writing 0 because that will be the x-axis anyway. I'm going to click on graph. Here it comes from 0 down to -infinity. From positive infinity crossing that 0, 1, and I don't see it. But we can zoom in. So if I change the viewing window, let's say between -1 for x and 2 for x, and for y between 0 and 2, I should see a little opening right here at 1, 1/2. Thank you. If you have any questions.